Hello, welcome again. We are covering the subject thermodynamics for civil circle MECH, IFS and various GATE exam. Next topic in the chapter of thermodynamic relation is Clausius claperyon equation. So this equation is related to phase change like melting, evaporation and sublimation. So we know that during this phase change or phase transition, the temperature and pressure remain constant while entropy and volume changes. Okay, suppose we have initial phase represented by I and final phase represented by F, and the transition is taking place, and X fraction of initial phase has been transformed into final phase. Okay, then at this instant the contribution of final phase will be at Xf, and the contribution of initial phase will be at 1 minus xi. So this will be a total entropy. So that is the part of initial phase and that is the part of final phase. Similarly, for volume, this is the part of initial phase volume and this is the part of final phase volume. Okay, and as entropy and volume are linear function, right? Okay, so now if we have constant temperature during transition, like melting, evaporation, sublimation, then and during melting we are, or during evaporation or during sublimation we are supplying heat for the transition. Okay, so that is not from the temperature change, so it should be from the entropy change. Okay, so that heat is your temperature into entropy change, final entropy minus initial entropy. Okay, and that heat is called latent heat of evaporation. So there is entropy change. Okay, so entropy change as well as volume change, but temperature and pressure would remain same. So now we will take change of Gibbs function. The formula is minus s dt plus v dt. Okay, and if we keep the pressure constant, then entropy changes. There will be entropy. The entropy will be equal to minus curly g by curly t p constant. If we keep here pressure constant, then this will be 0, so S will be this value. Similarly, we can find out if we keep the temperature constant, then this will be 0, then curly g by curly t constant will be this value. So it means S is function of change in Gibbs function and V is also function of change in Gibbs function. Okay, so the Gibbs function has to change to satisfy or to find out to satisfy this condition and this condition. The pressure and temperature are constant during this. So Gibbs function, change in Gibbs function has to satisfy this also, and change in Gibbs function has to satisfy this also. Okay, so it is changing this continuously. So this is the first order equation, and so phase change equation is your first order equation, and it should satisfy the following requirement. First, there should be change in entropy and volume that we have studied, and first order derivative, this is first order derivative of Gibbs function, change this continuously to satisfy entropy and volume requirement. Okay, so now we'll drive the Clausius claperyon equation. From first TdS equation, we have TdS is equal to Cd dt plus T curl P by curl T V constant d. Okay, so now during transition or during phase change, temperature remains constant, so this quantity will be 0. Pressure also remains constant, so curly P by curly T will be a constant quantity. Okay, so curly P by curly T will be a constant quantity. Okay, now we'll integrate this. So this part will be at T Sf minus Si, and here this is constant, and this will be your Vf minus Vf. Okay, from this we will get dP by dt is equal to Sf minus Si by Vf minus Vf, and Sf minus Si is your latent heat by temperature. So this will be a dP by dt will be a L by T bracket Vf minus Vf. So this is known as Clausius claperyon equation. Okay, so this is the one of the way to drive the Clausius claperyon equation. The other way is to To drive the classification is that the Gibbs function remains constant during transition. However, it changes, but the changes is such that the final Gibbs function and initial Gibbs function is same. Changes is to satisfy the requirement of entropy and volume. But for entropy change, it changes in some other way, and for volume, it changes some other way. But net effect is that there is no change in Gibbs function. So initial Gibbs function and final Gibbs function are same. So from the formula dg, we have, if we take initial condition, then it will be minus si dt plus vi dt. And if we take final condition, then it will be sf dt plus vf dt. Okay. So now dp by dt will be equal to sf minus si by vf minus vi. Okay. So this is the again same form as we have got previously. So this will be L by T vf minus vi. So this is your Clausius claperyon equation. Now we will use this Clausius claperyon equation for various phase change. First of all, we will take fusion. So if we take fusion, then here it will be written to fusion, and this for Vf is for V double dash. V double dash is saturated liquid state volume, and I will take V dash. So that is saturated solid state volume. Okay. So that is your change in volume of ice during melting. Okay. Or substance during melting. If we take the case of ice, then this change in volume is negative. So this quantity will be negative. So slope will be a negative. So fusion curve will be a negative for water. Like this. Will have negative slope for water. But for any other substance, it will be positive. Okay. Next case we will take the case of evaporation. So for evaporation, dp by dt will take latent evaporation, and this is your boiling point, and this volume is your saturated vapor state volume, and this volume is your saturated liquid volume. And we know that saturated vapor volume is very very high as compared to saturated liquid volume, so we can neglect this, and we can assume that this vapor state is following ideal gas equation. So then B triple dash will be equal to RT by T. Okay. So then this equation can be modified. Neglecting this can be written as L evaporation L is equal to T dP by T RT by T. Okay. Or L evaporation is equal to RT square by T dP by T. Okay. If we know dP by T, then we can find out L evaporation. Next case is of sublimation. So for sublimation, we will take latent of sublimation, and here we will take V triple dash, and here we can take V single dash. Okay, so L sublimation is your latent of sublimation, and V triple dash is very very large as compared to V single dash. So V triple dash will be equal to RT by T. Same way that we have done in evaporation. So this can be neglected. So then this will be dP by T L sublimation by T RT by T. Okay. So now this is these are the three cases. Now we take the triple point. Then at triple point, L sublimation is equal to evaporation plus fusion, because solid is changing into vapor, so it will contain evaporation heat as well as fusion heat. Okay. So if we consider evaporation, then we will take the triple point pressure here, triple point temperature here, L evaporation here. Okay. If we consider sublimation, we will take triple point pressure here, triple point temperature here. Okay, same formula, this formula, and L sublimation. Okay. So but L sublimation is more than this L evaporation, so slope of sublimation curve will be more as compared to slope of evaporation curve. So this is your at triple point. So this is your Clausius claperyon equation.